Alright, so I'm going to say character star ABC. And we'll set star ABC to the string "this is fun." And PTR is still going to be a pointer to characters. And if we want to print the value of ABC as a string, we can use a %s. And so let's get rid of all of this. Right, so ABC is just a string. This is fun. So that's using a char star, right, a string in the usual sense. But let's also, if we say PTR equals ABC, it's like PTR is pointing to the string, which says "this is fun," but it's really just a pointer to this actual collection of characters. This is fun. So let's print out the value of PTR. Let's see what it's equal to. So PTR is a different funny looking hex number. And notice before, when it was a pointer to a character or an integer, it started with a 7FF. But now it's starting with a 55934, and so on and so forth. And if we run this again, right, it's going to point to a different location, but it's still a fundamentally different address. It's this thing that starts with a 5 instead of starting with a 7F. It starts with a 55. And that's significant, but it's not really relevant to this discussion, but it's something to be aware of. Okay, so PTR is basically pointing to this string, this array of characters. So if we were to print out PTR, as a character, and I'm making typos this morning. Right, star PTR is the letter T, which is the beginning of "this is fun." And if we increment PTR, then PTR points to the letter H. So this is what we were doing when we had separate variables A, B, C, because when we said character A, comma B, comma C, they happen to be laid out next to each other in memory. But with a character array, what we call a string in C, right, each of these characters is stored in a successive location in memory. And so if we increment pointer, it used to point to the first character, and now it points to the second character. Okay, so that's exactly how we can work with arrays. So if we increment the pointer a number of times, right, we get "this is," and let's just go through the entire array, right? So pointer points in succession to the letters from the sentence "this is fun." Okay, well, we can also get rid of all of this. Because pointer can be treated like an array. So if we print out pointer bracket 0, that's going to be the letter T. And if we use pointer bracket different values, that gives us the successive elements inside this array. Right? Because This means give us the thing pointed to by pointer plus 4. Pointer bracket 4 means take the value of pointer, add 4 to it, and show me what's at that address. And so it's the same thing as incrementing the value of PTR 4 times and then saying print out star PTR, right? This is why arrays and pointers are basically the same thing. Because when you have an array of characters, you really have a pointer to a location in memory. And when you say star PTR, you're saying what's at the location PTR. When you say star PTR plus 4, you're saying what's stored at the location 4 plus the value of PTR, but that's what PTR bracket 4 is a shorthand for, right? This just means take the value of PTR, add 4 to it, and show me what's at that address. And we can do that. Let's just take PTR, add 4 to it, and see what's at that location, and it's our space. And let's look at we should have 10 characters here. Right, so pointer 10 is the last character of that string. Alright, so that's the basic setup with arrays. So we can also look at these characters as integers. So instead of doing %Ds, %Cs, let's do Bs. And let's look at the whole string. Right, so here we're looking at the ASCII codes for the string. This is fun. 84 is a T, 104 is a lowercase h, 105 is lowercase I, right? I comes right after h. 32 is a space. That's a good one to memorize because it bumps up a lot, no matter what your words are. And 110 is the letter N. Okay, so that's the last character of our array. So what do you think happens if we look at element 11 in our pointer array? Because we only have elements 0 through 10, right? 11 letters. This is fun. So let's take a look at one more spot. Let's look at element 11. And if we do that, element 11, well, that's a 0. And that's the famous null terminator that we find at the end of strings. So when we write a string in quotation marks and say, quote, this is fun, these get stored into memory locations starting at some effectively random location. Gets a T and then an H, IS space, FUN. But then the compiler puts one more location into the next spot in memory, and what it puts in that location is a 0. And that's called a null terminator, and it's just a convention so that if we have code that's working with this string, it can start at the beginning of the string and it can read successive locations until it reads a character whose ASCII code is 0, and it uses that as a flag. It says, okay, that's the end of the string. And so if we pass this to printf, for example, with %s, it'll print all the characters up to but not including this null, this 0. If we use string length, it'll start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters, and then when it sees the null, it'll say that's the end of the string. And it would return a length of 11 characters, right, which are characters indexed 0 through 10. So that's the famous null terminator. All right, don't know if that helped or not, but hopefully it helps somewhat. All right, take care. Bye.